Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Rio Adi Prasetyo. I'm from Engineering Physics Department, and today I'm going to explain about flow control valve, the diagram, working principle, types, and application. This is the assignment of the lecture Instrumentation System with the lecturer Dr. Suyanto as the MT. This is the outline of this presentation. First, we have introduction. Second, we have explanation. Third, we have an application. And then last, we have the summary of this presentation. The introduction contains background, problems, aims, and contributions. Background. It is impossible to design a practical fluid power system without some means of controlling the volume and pressure of the fluid and directing that flow to the proper operating units. This is accomplished by the inclusion of control valves in the hydraulic circuit. A valve is defined as any device by which the flow of fluids may be started, stopped, regulated, or directed by a movable part that opens or obstructs passage of the fluids. Valves must be able to accurately control fluid flow and system pressure, and to sequence the operation of all actuators within a hydraulic system. Hydraulic control values can utilize a variety of actuators that activate their function. Normally, these actuators use manual, electrical, mechanical, or pneumatic power source. Problems. Flow control valves are used to regulate the flow of fluids. Control of flow in hydraulic system is critical because the rate of movement of fluid-powered machine or actuators depend on the rate of the flow of the pressurized fluid. It is important to understand about the parts of flow control valve and the types of flow control valve that is suited for specific process, so that the actual results of the process is matched with the expected results of the process. Hydraulic flow control valves provide a cost-effective solution to concerns surrounding the flow rate. However, they are not without their problems, leading to a loss of pressure when valves are partially obstructed, which can impact performance. Which more bas- with more basic flow control valves, change in flow rate may occur even when the control valve is in a static position due to system pressure, temperature, which alter the viscosity of some fluids or other variables, leading to reliability concern. Selecting the right hydraulic flow control valve can address some of these concerns, although completely mitigating these issues may require a sophisticated control valves, such as pressure and temperature compensated variables control valves. Aims. The aims of this instrument review is to explain about the parts, the types, the working principle, and the application of the flow control valve. A flow control valve in any hydraulic system is tasked with the regulation of fluid speed, and by regulating the rate, it can control the speed of an actuator in the system. The contribution. Flow control valve can serve a number of different functions within a hydraulic flow system depending on the specific types that is used. One of the most common use of a flow control valve is to regulate the speed of motors or cylinder within the system. This function is possible due to capability of a flow control valve to affect the rate of energy transfer at any given point in a system by impacting the flow rate. Explanation. Basic concepts. The valves which are mainly used to regulate the flow of fluid in hydraulic circuits are known as flow control valves. The flow control valves are widely available in many different types according to their use. In hydraulics, Flow control valves are used to control the amount of oil supplied to various parts within a hydraulic system. In this way, the momentum of a cylinder or the rotational speed of a hydraulic motor can be controlled. However, a basic flow control valve has an opening that can be changed to increase or decrease the flow rate. Many benefits of using flow control valves include the variety of materials from which they can be made, such as brass, carbon steel, stainless steel, and zinc. Flow control valves can provide many choices for simple or complex systems. They adjust for pressure, temperature, and other flow variables. The working principles. The flow of a fluid can be controlled by changing the place through which it is passing. In this, a pressure drop occurs, and this must be considered when choosing a flow control valve. In a hydraulic circuit, the pressure fluctuates across the loads, sometimes more or less, although the inlet pressure is constant. The pump is delivering fluid at constant pressure, but the outlet pressure can vary. To avoid this fluctuation inlet, we can easily install a pressure-compensated flow control valve. By using this flow control valve, the flow rate can be kept constant even under a variable load. These valves have a spool, and by changing the position of the spool, the field direction of the passage can be adjusted. Therefore, the required flow can be maintained during the flow of the fluid through the valve. And then this is the diagram of the flow control valve, which contains hand wheel, wheel sleeve, bonnet bolt, body, valve backing, bonnet, stem, disc, and seats. First, the body. It is the main part of the flow control valve, in which all other parts are kept together by a structure called the body. The piping in the valve body is achieved with the help of bolts and welded joints. It is usually made of cast iron and is also called a valve shell bonnet. The bonnet is a cover that is used for the opening in the body and is divided into two parts, which are fastened together. Some valve bonnets are used only as a cover, while some of them are used for valve interior accessories. And then the trim. The trim is usually presented on the inside of the valve and consists of the stem, sleeve, seat, and disc. Uh, Valve performance can be detected by the seat and disc interface. Disc and seat. A disc is an essential part of the flow control valve that allows and restricts fluid flow. If the disc is in a closed state, then the total system pressure is applied to the disc, and the pressure is exerted toward the outlet stem. These are liable for the connection of the actuator and the disc, which holds the disc in positions. The connection is done by the thread welded joints welded joints. Generally, two types of the stem are used, which are non-rising stem and rising stem. Actuator. This is the main part of the flow control valve, which is driven by the stem and disc assembly. Control valve actuators may be operated manually or by an electric motor. Hand wheel. It is a common type of a valve actuator. A valve hand wheel is used to manually control the opening and closing of the valve. Valve backing. It is a sealing system that has the deformable material in the solid form or split rings held in the packing box. These are used for packing in valves, which consequently prevents leakage between stem and bonnet. And then we have uh, the type of flow of the types of flow control valves. Uh, in this assignment, uh, I put 10 types of flow control valves, which is gate valve, plug valve, needle valve, non-return valve, butterfly valve, pressure compensated flow control valve, pinch valve, group valve, diagram valve, and ball valve. The gate valve. The valve control the flow of the oil in a pipe by moving a flat plate called a gate or a disc valve. Gate is built perpendicular to the length of the pipe with the help of hand wheel. The mechanism is achieved by connecting the gate with the hand wheel through a threaded spindle that rotates in a valve body. The advantage of a gate valve is that it offers little or no resistance to the flow when it is fully open. It is usually made of a gunmetal. Plug valve. As the name suggests, this valve is having a plug. This plug can be turned to move its part to control the flow of oil, and it features to reduce the friction between the plug face and the body seat when the turning of the plug. The valve consists of a tapered wedge mechanically seated in the body. The tapered edge has a rectangular window. When the valve is fully open, the rectangular window aligns itself with the hose running through the valve body. The needle valve. It is a kind of screw-down stop valve. It's used to restrict it to small sizes which have the body ends in line or right angles with each other or maybe oblique type. Here, this is in the form of needle point. By rotating the hand wheel, the tapered needle advances, and the area of the valve tip decreases. Hence, the outflow is gradually reduced. These valves are used in hydraulic systems in lines or of delicate pressure gauge. The non-radial valve. The non-radial valve permits flow in one direction and stops the flow completely in one direction. It consists of a valve body, a poppet, a spring, and a seat. When the force of fluid is available at the inlet part exceeds the strength of the spring and the back pressure of oil, the poppet is pushed up and the valve opens to permit the flow through it. When the oil is flow when the oil is flow is reversed, the valve piston is pushed back to its seats, completely blocking the flow. Butterfly valve. Butterfly valve has a circular disc that can be rotated through one complete revolution. Circular disc has a diameter equal to that to the pipe. The valve is connected across both faces by two pipes with flanges. A circular disc is made to rotate around an axis passing through the vertical diameter of the disc. This type of flow control valve is used for controlling moderate flow. Pressure compensated flow control valve. Uh, this control valve provides a uniform volume flow rate independent of the pressure drop across the valve. On the other hand, the non-pressure compensated valves have a variable flow rate that changes as the pressure in the valve fluctuates. Pinch valve. These are types of flow control valves which are inexpensive and are used in almost all industries. It consists of flexible elements such as rubber tubes for sealing purpose. They are designed to give a tight seal around trapped solid with their flexibility. These rubber tubes are the moistened part in a pinch valve. Pinch valves are perfect for liquids that contain large amounts of suspended solids. The valve body acts as a uh, built-in actuator, reducing the need for expensive apparatus such as pneumatic hydraulic or electric operators. The globe valve. These are considered valuable for starting, stopping, and regulating the flow in a linear motion. Uh, Globe valves are used for throttling application because the disc of the valve can be completely removed from the flow line, and are also capable of closing the flow line completely. The diaphragm valve. These valves are built to handle conditions that require erosive, corrosive, and dirty surfaces. It consists of flexibilities that reaches the top of the valve body along with the seat to form a seal. These are used to control the opening or closing of the valve. These valves work by an electromagnetic diaphragm in the valve body rather than electromagnetic liner, which is attached to a compressor to isolate the closure element from the fluid flow. This gives the advantage that they feature a leak-proof seal and are easy to maintain. And the last is the ball valve. Ball valves are commonly used in a variety of industries because of their low cost, durability, and excellent closing capability. These are similar to a butterfly valve, but they are not suitable for flow control application as they require high accuracy and control. This is because a high level of torque is required to open and close a ball valve, which prevents an operator from making fine adjustment. Ball valve is used for filling a tank with reasonable accuracy. A Tronian or Freeport ball valve design is usually the best type. Then we get the applications. The process plants consist of hundreds of or even thousands of control loops, all networked together to produce a product to be offered for sale. Each of the control loops is designed to keep some important process variables such as pressure, flow, level, or temperature within a required operating range to ensure the quality of the product. Each loop receives and internally creates disturbance that detrimentally affect the process variable, and interaction from other loops in the network provides disturbance that influence the process variable. To reduce the effect of this load disturbance, sensors and transmitters collect information about the process variable and its relationship to some desired set point. A controller then processes this information and decides what must be done to get the process variable back to where it should be after a load disturbance occurs. When all the measuring, comparing, and calculating are done, some type of final control element must implement the strategy selected by the controller. The most common final element in the process control industries is the control valve. The control valve manipulate uh, flowing fluid such as gas, steam, water, or chemical compounds to compensate for the load disturbance and keep the regulated process variable as close as possible to the desired set point. Then, the summary of this presentation. Control valves are normally fitted with actuators and positioners. Pneumatically actuated clip valves and diaphragm valves are widely used for control purposes in many industries, although quarter-turn types such as modified ball and butterfly valves are also used. Uh, Control valves can also work with hydraulic actuators, also known as hydraulic pilots. These types of valves are also known as automatic control valves. The hydraulic actuators respond to change of pressure or flow and will open or close the valve. Automatic control valves do not require an external power source, meaning that the fluid pressure is enough to open and close them. Flow control valves are used for plumbing, mechanical, and gas distribution applications. Therefore, there are many factors to consider when selecting a suitable flow control valve, such as media type, valve function, application conditions, actuation methods, and maintenance requirements. That's all from my explanation. Thank you and see you later.